Thank you, Greg, for that very kind introduction and for inviting me here. And in case you're wondering, yeah, it's my real name. It was just dumb luck. I actually have a lot more in common with you folks than you might think, despite the fact that I taught wildlife conservation and wildlife management at McGill University for 40 years. I grew up in Ontario as an Air Force brat, and I basically developed my strong interest in wildlife, hunting, fishing, all that stuff, while moving in various places, in Air Force bases in Ontario. And I just recently, I came from the West Coast because I just recently moved there within a year ago to North Saanich, just near Sydney on Vancouver Island, which is a home of a lot of great salmon and halibut fishing. I'm into fly fishing, and I'm actually taking up elk and deer hunting as well. So I have a lot in common with you folks, and I also happen to be a very good friend of Robert O'Bailey, which I'm sure some of you know. I could tell you some great stories about Bob Bailey if we had some time. All right. The word drones, it stirs up certain images in people's minds, and I know what images it puts in your minds. It puts in images such as killing and spying on people. It also conjures up images of having your books or other supplies delivered to you by Amazon.com, which to me was nothing more than a big publicity stunt, although they think they're pretty serious about it. Or having beer delivered to your cabin, your hunting cabin or your ice fishing hut like one guy did before he got nailed by the FAA. Or you can even buy a Renault, a small car from Renault, and get a drone thrown in so you can throw it up in the air and see what the traffic's like ahead. I'm sure that's not going to happen either. The fact is, a drone is a male honeybee, or it's a target drone, meaning it's something that the military sends up to be shot down. The fact is, there really should be called unmanned aerial vehicles, which are those things you see in the pictures down below, fixed wings or rotary machines and so on. But that ship is really sailed, because the fact is the word drone, a lot of us don't like the word because it does conjure up all these terrible images. The fact is that it's in the public's head now. We're never going to get rid of it. So I will probably use the word off and on occasionally. My objectives today in this talk are to give you some sense of why drones might be good for wildlife research and management, identify some of the key players, although I'm not going to spend so much time on that because I've got some more important things to talk to you about. And I want to cover some applications for wildlife and then discuss some of the challenges that we're facing both in the technology side and the non-technology side. The fact is that the drones were used by and still are used by the military in a big way before anybody else got into them for civil applications. And they had plenty of money to spend on these things. Some of those drones cost millions of dollars. When I first heard about them about 7 years ago from a friend out west, I didn't even know what a UAV was, and I wasn't sure what even drones were. But I have a very active imagination, and I started thinking of all kinds of ways that I could use these things as a raptor biologist, which I'll show you in a few minutes. And this is just a partial list of some of the civil applications that unmanned aerial systems could be used for. Everything from first responders, a lot of police forces are buying these things now, Arctic surveillance. And the ones in red there are the ones that would be of greatest interest to you and me, power line monitoring, environmental surveys, and land and forest surveys, and wildlife surveys, and so on. This is basically an outline of some of the applications that I saw out there that they could be used for wildlife research and management, and I'm going to go through each of them and give you some examples of them. Starting with population counts, everything from herds of large game, looking at flocks of birds of various kinds, even schools of fish. I know there's a group in the University of Florida using them to count salmon stocks in Idaho rivers, or looking into hard-to-access nests and underground burrows and so on and so forth. From terms of population studies, things like snow geese or beluga whales or ungulates or sea mammals and so on are ideal critters to count with such machines. And let's take a quick look, though, at the sort of the older technology that's using a manned aircraft and the disadvantages and advantages of both. For example, if you're using a Cessna or a helicopter, you can cover very, very large areas, and you can get angles and reach places that are inaccessible from the ground, and they're really good for wide-ranging mammals. The use of planes and helicopters is not going to go away. But the drawbacks is that they're cost and logistics. You have a lot of, there's the rental of the plane and the pilot and the cost of the fuel, and you got to coordinate a lot of things. There's some debate over methods and accuracy. disturbance concerns and safety concerns and so on. And it's not exactly the most green way of going out and counting wildlife. So some of the advantages, there are a number of advantages from using these things for wildlife biologists. How many people in this room know of somebody who's been killed in a plane or a helicopter crash for professional reasons? Okay, I asked this question at a wildlife conference in Pasco, Washington, about the same number of people in the room, and about 90% of the people in that room, they're mostly Americans, put their hands up. The fact is, the #1 source of mortality for biologists is dying in a helicopter or a plane crash. So that is reason enough to think about using drones as an alternative. They're initially more expensive. Right now, they're still a bit costly, but they're coming down in the price. You can fly at much lower altitudes with them safely, and you can fly at night with them. You actually get better image data from them. You can drape the images and so on. Less obtrusive to wildlife and more green overall. So there's a lot of good reasons why you might want to use these things. I first got involved with them, as I said, about 7 years ago with a grad student, Dominique Chabot. He just got his Ph.D. about 3 weeks ago, where he studied water birds with using a plane like this. This is called the Aerial Insight Multi. It stays up for about an hour and a half, and it's electric, and it's quite quiet, actually. You'd be surprised how quiet these things are. And we had a project in Quebec National Park in New Brunswick, and there's a very large tern colony there, sort of averages around 5,000 to 6,000 birds. It's the second largest colony in North America. And the problem with that colony is it's basically a couple of sort of barrier islands made out of sand. And over the years, the sand is eroding away due to changes in the ocean levels and so on due to climate change. And so they want to know how those birds are using those islands and how many there are and so on. And so the traditional way of counting these terns, and I've actually partook in this myself, is to make a human chain, and you walk along the islands back and forth like this, wearing hard hats, because these birds basically rise off, and they get pretty freaked out. I mean, they don't sit there in their nests and wait for you to come along. There's like thousands of them flying above your head, and there's poop flying everywhere, and they basically try to peck you and draw blood to chase you away. It's not the most unobtrusive way of doing a count, so we wanted to find out whether these planes could help with that. So here's my student with one of the technicians out there getting ready to launch the plane. And that yellow line that you see, broken line you see there, is the path that he put the plane up. And I was there for on the very first day he flew the plane. And initially, the plane was flying at about 300 feet high, about the size of a bald eagle. The birds did rise off their nests. But the second time, less of them rose. And the third time and fourth, and after that, they didn't care anymore. The plane wasn't going to do any harm to them. And so this is just a picture of one of those islands taken by a camera from it was just a point-and-shoot camera, and you're looking at it right now and you're saying, well, where are the birds? I don't see any birds. Well, you blow the picture up there, and if you could sit closer to the screen, you can see every one of those little white dots is a tern on its nest. And so we were interested in more than just counting the birds. We also wanted to find out how they were using the island, where did they make their nests and so on. And by doing some, taking all these images and getting counts of the birds and actually finding out where they nested on the island, we were able to use imagery analysis and fancy statistics and so on to get an idea of what kind of ground cover did the terns like best of all on those islands. And the second objective was to see if we could get the same kind of counts as the ground crews. And in fact, the ground counts in that particular year were 2,372 birds, and using the plane, we got 2,426. It's about 94% of the birds, which isn't bad, really, if you're just looking at trends. You don't have to count every single bird. Another area that I'm using drones with my grad students is looking into birds' nests. This was the very first thing I ever thought of, was saying, gee whiz, if I could take one of those hovering helicopters, I could put that above a bald eagle's nest, for example, and look into the nest and not have to climb up to the nest. Because birds of prey traditionally nest in very inaccessible locations, places like on cliffs or in tall trees 100 feet up, or even on city skyscrapers, or vultures, for example, and eagles nesting in acacia trees, thorn trees in Africa, not easy places to get to. And so I hired a guy about 3 years ago to go to the Arboretum with me to fly a dragonfly. You can see it in the bottom picture there, above a red-shouldered hawk nest. And the first two things we found out is that because of that thick canopy, the signal from the orbiting satellites couldn't reach the GPS unit on the plane, so he had a hard time keeping it stable. And secondly, it was also hard to manipulate that machine around all the branches and so on. So maybe these machines are not going to be so good for raptors that are nesting in thick canopy like red-shouldered, broadwing hawks, or goshawks. Another thing I know about birds of prey, having studied them for 40 years, and Martin, who's in the audience, knows this all too well, is that birds like goshawks, birds of prey like goshawks and great horned owls, will actually try to kill you if you go near their nest. They are extreme defenders of their nests, to the death almost. And if you put a helicopter of any size near one of their nests, they're definitely going to smack it. There's no doubt about it. And so that brings up two images in my mind. One of them is your $7,000 plane gets wrecked, or worse, the bird gets hurt. And so that's not going to fly by animal care committees. So some possible solutions that we're looking at are maybe putting a cage around the, maybe made of Kevlar like the top right-hand picture, or a plastic cage around the planes, or cowls around the propellers. We're looking into that stuff right now. You might think, well, why don't you make them really small so that they, that they don't present much of a threat to the birds? But I also know that the smaller they are, even the more likely that all of the birds of prey will attack them. So that's not going to work. Look how small these things can be. These things actually have cameras on them. But these little tiny ones cost hundreds of thousands of dollars because they're owned by the CIA and all those guys. And so we're not going to get a hold of those. And what about making them look like other animals, like a hummingbird or a dragonfly? Well, I happen to know that merlins, one of their favorite prey is dragonflies. They would eat one of these things if we put it, making it look like a food item. There's no doubt about it. In fact, a professor in Florida was telling me he specializes in macro vehicles. They're little tiny micro vehicles that are little tiny ones that sit in the palm of your hand. And he told me that he put one out on the campus and put it up in the air, and 5 minutes later a hawk came along and flew off with it. So, they're pretty expensive little toys to have that happen. So I took on a grad student, James Junda. He's still with me now, and he's looking at behavioral responses. That's really what I'm interested in, of different kinds of birds of prey to these planes, so particularly quadrotors. We're working with Eric Green, who's a professor at University of Montana. And this is the plane we're using. It's a Dragonflyer. It's from Saskatoon. Costs about $7,000 for a basic machine, but I'll come back to that later. You can spend up to $45,000 if you want a more powerful one. And this is a typical picture that you can take with these helicopters over nest. There's, I think that looks like 3 or 2 ospreys in that nest taken with a machine. And this past summer, we flew 86 flight surveys over 41 active nests and compared that to the ground surveys that Dr. Green was doing using a cherry picker. And very quickly, we found out we got exactly the same counts looking at our pictures versus him climbing into the nests. And we also found out that this way, where you had to back the truck in and you move the thing up and down, the ospreys are freaking out and flying around the whole time. Well, we could do this. We could be in and out of the nest in 6.5 minutes, and the actual flight time of that UAV over the nest was about 3 minutes. And we got actually better at it as we went along. So 3 summers ago, and we're actually going back to Saskatchewan, we flew a dragonfly over a ferruginous hawk nest. And also, this is what we saw. We had a baby bird, like a young hawk in there, and a dead nestling that the guy who was studying the birds didn't even know was there. And meanwhile, the parents in this particular species didn't attack the plane at all. They just sat on a fence post about a half a mile away, didn't even care. So there's various differences. And this is why this year and beyond, I've got some grant money to go to various places, look at bald eagles in BC or Saskatchewan, harpy eagles in Panama, martial eagles in South Africa, gyrfalcons in Alaska. And yeah, I do get a lot of students that want to volunteer to come with me, of course, and go to all these sexy places. The second area where you can use these drones is for habitat and range mapping. Everything from endangered species, nuisance species, changes in the habitat due to insect outbreaks or whatever, or inaccessible places. And this is a typical picture you can get, showing some farmland with some forests, showing different kinds of aspects of that thing that you could set up for, where hunter access or game management or whatever. And you could stitch these photos together because you do get a lot of images. And there's programs out there that allow you to stitch the photographs, and you see one like this, for example. Farmers have been using these things for quite some time. There's a company out in Manitoba called Micropilot, Winnipeg Micropilot, and they make the software for a lot of these planes that allow them to go up there, and you program them with your computer to fly a certain path. I'll tell you more about that shortly. And the first plane they ever produced was called a crop cam, cost about $10,000. I bought one. And it lasted for a couple of years for us to do some goose surveys, which I'll show you later. And then it just wasn't very rugged. And the way this thing lands, it belly lands in a grass field or whatever. So you can imagine that this thing eventually got covered in duct tape and super glue and all sorts of things. But here's a typical picture that you can get if you're into looking at habitat and wildlife and habitat. And you can use a hyperspectral camera, for example, that'll actually turn it into a pretty colored map like this, and all of those different colors represent, different kinds of vegetation or water or whatever. And you can set these cameras up to represent whatever you're looking for. And in the end, you can produce sort of rangeland mapping. Andrea Liberté, featured at the top of the slide, has a company, and she's a specialist in rangeland mapping. And so if the top left-hand corner, you can see the actual picture that she took, but turning into with a hyperspectral camera, you get this colorful thing, and allows you to look at, how much of the ground is bare, how much is shrubs, and so on and so forth. A third area that you can use drones for is distribution and location of wildlife. Things like where are the animals in space, where are they in certain times of the year or certain times of the month or whatever. Radio tagged wildlife and detecting illegal hunting activities. Again, Dominique, as part of his Ph.D., used a UAV, a more rugged one, the Aerial Insight Multi, that he was using for the terns, to look at threatened least bitterns. If you don't know what least bitterns are, they're like a little tiny, secretive, small heron-like bird. They're in trouble in Quebec, and there was an interest in knowing in this particular area. This area in Baie du Fave is a Department of National Defense property, and the Canadian Wildlife Service is very interested in knowing how the least bitterns were using the habitat in this area. So essentially, this was just a bit of a close-up of the area, and they wanted to have a management plan. So they enlisted me and my student to go there with this plane, and we basically wanted to relate the bittern density in this wetland to the habitat parameters. In other words, what kind of what vegetation in the habitat or water levels did the birds like the most? And also to use this to assess wet-scale habitat trends over a 5-year period. And so what the biologists, the Canadian Wildlife Service, did the ground truth thing, and they basically use playback calls, and all those little red dots and green dots and yellow dots represent where bitterns were in that little area. And then Dominique flew his plane, hand-launched like this, over the area, programmed it, and this is what you see on your computer. So Dom would sit there before the plane would take off and program all those little purple dots in that grid pattern, and then launch the plane, and it would descend to the height that he had programmed it for, and then fly back and forth and take a picture at every one of those purple dots. And then he would have all these records of the habitat below. And this would be a typical picture he got from an altitude of 900 feet. And he could use these and use some fancy image analysis and statistics to come up with, for example, this kind of sample result showing that the cattail cover was extremely important to these bitterns. And he could produce linear regression models, and we found out that the percent cattail cover and the water vegetation edge were presented the best model as to where you could find least bitterns. Another area that really interests me with drones is using them as sort of antenna or receivers in the sky to track radio-tagged animals. I mean, it's well known that biologists all over the world are tracking sea turtles and small birds and elk and caribou and whales and so on with transmitters of various kinds. And so someone asked me once after a conference whether you could put up a UAV in the air, high in the air, and use it as a way to pick up signals from these animals. And there are 4 major categories of drones you could do this with. There's actually static balloons, like you see in the top left, that you fill with helium, which are tethered in one spot, or you can use a helicopter of various kinds with 4 props, 6 props, doesn't matter. In fact, a friend of mine in University of Victoria is working on a tethered rotary drone right now that has an electric source going to it, so it means it can stay up in the air indefinitely. You can just put it up in the air over an area and have it whir around until the motors run out. And then you could use a fixed wing, like the bottom left there, or even a kite. That also qualifies as an unmanned aerial vehicle. And so these 2 professors at University of Western Ontario and University of Victoria approached me after one of these talks a couple of years ago at a bird conference and asked me in the Gulf Islands, where they were doing some work on song sparrows there and looking at predation risks, they asked me, do you think you could put up one of your drones above these Gulf islands so that we don't have to get out of our boat and walk around with a Yagi antenna in our hands and spend hours trying to get a signal from our sparrows to see if they're back yet? And I said, I think we can do that. So my partner, Paul Pace, in the lab, got a transmitter and a helicopter, and sure enough, we can easily pick up the signals, and that's exactly what we're going to be doing, field testing this spring with them. And then I got involved with a really neat study in Goose Bay, Labrador, in Five-Wing Goose Bay. They, Department of National Defense there has control over a humongous area of, for basically bomb testing and so on. And I've been watching this Ukraine-Russian thing with great interest because, Goose Bay, Five-Wing Goose Bay is in danger of being closed down. They don't know what to do with it. And I have a funny feeling we may be heading for another Cold War. So it looks like we may be having a lot of those jets going back there again for practice for flying over low-level flights. Anyway, they have woodland caribou herds. They've got 3 of them there, and 10% of the animals are wearing satellite transmitters and also VHF transmitters, the regular ones at very high frequency. And essentially, the Department of National Defense needs to know where these animals are because they're not allowed to fly their jets over these animals and disturb them because they're listed. And so every month with the satellite tracking, they get a picture like this, and every one of those dots represents a caribou. What they don't know, though, is they don't know if one of those dots represents one animal or a whole herd of animals. And so they'd like to have a UAV. Basically, you launch the UAV, it flies over the territory, beyond visual range, which I'll come back to later, and picks up the signal, goes to the signal, and then automatically over top of that signal it descends to the right height, 300 feet, say, and goes back and forth and takes pictures of what's below, then comes back to base, and then we get pictures, then we know what's there. That's the essence of the work. We're slowly getting there. I took on a grad student, Charlotte Patterson at McGill, still with me now, and I've got a big team of guys, and this is typical habitat in Goose Bay, and you're looking at this picture and you're saying, how the hell would you ever find a caribou in that? Well, the fact is the caribou there like to spend a lot of time in these bogs. They don't usually go out in the middle of the forest and so on, so that's where I definitely would focus. And we can use these special lenses on the cameras to actually turn the caribou into a purple dot, like you can see in this picture here. And so you can actually count these animals that way. You can see them. And this is the team. We were there last September, and this is the plane we're using. It's called the TD-100. I'm trying to get the owner of the company to call it the Black Brant, but he's resisting. And this is the team of guys we brought with me. It's basically a plane that you launch with a pneumatic launcher. There was a runway there. What D&D did for us there is they shut down all of the airspace in certain portions of each day so that we could fly our plane without having to worry about it hitting a military plane or a Cessna filled with fishermen or something. And so that's why we were able to fly beyond line of sight. That's what BLOS stands for, beyond line of sight. It's the holy grail. It's what we all want to be able to do with these planes, is launch them so that you can't even see them, but right now it's against the law to do that. Another area that really interests me is nuisance wildlife, and I see the possibility of using these planes to disperse nuisance wildlife. And I have met people, biologists, who are also interested in using them to transport food to remote locations to draw away nuisance wildlife, like bears from campgrounds, for example, away from centers of human activity to more safe places. And I just talked to a guy who's working on a very powerful drone that would be able to carry large chunks of food items. But that's not my interest. My interest is more this. I'm a bird guy, and I happen to know that around the world there are a lot of nuisance bird problems. For example, top left, revving blackbirds ravaging experimental crops, or starlings in vineyards. You've got snow geese in the northeast, and I know you guys are doing your best to help out with that problem. No competition from these drones, that's for sure. But they're ravaging winter wheat crops in the northeast. Keelia in the bottom left are the most numerous bird in the world, and they can basically take out an entire rice crop in a matter of hours. They're like feathered locusts and cause whole villages to starve in Africa. And then you've got parrots in Australia that are ravaging crops there. Gulls at town dumps, airplanes around airplanes, which frightens the heck out of all of us. Cormorants in aquaculture facilities, and of course our favorite bird, the Americans like to call them Canadian geese because they're so darn obnoxious. The common way to scare these birds away from these various places are, of course, falconry is very effective, and also using dogs like terriers to scare away geese. certainly banger guns and various kinds of explosives, but also the most effective way is a shotgun. That's what they're using in a lot of places. They just simply kill the shorebirds at Vancouver Airport, or they kill geese, large numbers of gulls, and so on at JFK Airport. It's most effective. I am aware that probably as much as 40 years ago, scientists have explored the idea of using drones that look like birds of prey to supplant the use of real falcons, because they have their limitations. And there was a lot of interest in this, and there still is somewhat of an interest, but the fact is that the birds get habituated to these things after a while. They don't do them any harm. They just fly around and they maybe make some noise or whatever, but they don't do any harm. So they get habituated to them. They don't fly. I also know that companies over in Europe have developed these things, these UAVs, to very sophisticated ends that actually look like birds of prey. That thing in the silver thing in the top left actually flies just like a bird. The wings fly up and down like this, the tail goes up and down, the head even goes from side to side. And the bottom right, they've developed a bald eagle and a peregrine falcon that look just so much like the real thing that if you saw one flying around outside this hotel, you'd think it was the real thing. I also know in the news, as you well know, that there have been news stories of young men going there with these helicopter drones and scaring away geese from various places and so on. But I look at those pictures and I say, well, I could do the same thing with a terrier dog. I don't need to have a drone machine to do that. A dog will do the same thing. I think that we have to devise some way of making the birds a little more uncomfortable. Not maim them or kill them, but certainly making them hurt. Sort of like the old Farmer Brown story. That Farmer Brown was a guy I used to fear as a kid in Centralia because he used to walk around his property with a shotgun loaded with rock salt. And I think we need to do something like that. And I've got a grant to do that. And I'm working very closely with Transport Canada because they don't want me to be on national headlines showing me shooting things off. People are already freaked out enough about these drones without thinking, oh my God, they're going to start shooting rock salt at us and when we get into crowds or whatever. Maybe firing laser beams or something. I'm not going to do this. You can see that this guy here is actually blowing things up with his drone, and I'm not going to do this. This guy actually took his dead pet cat and turned it into a UAV. No kidding. He did this. And I know songbirds, like starlings, don't like cats, but I'm not going to do this. I can just imagine the death threats I would get from cat lovers. It's not beyond the realm of probability to use drones to assess mortality from power lines or from those tailings ponds in our oil sands project, or along wind turbine fields. But the problem is that until we get permission to fly these things beyond line of sight, this is hard to do. I mean, you can't be following your plane along, otherwise you might well just do it yourself. And you hear a lot in the news about using drones to capture, stop scenes like this, where this rhino is being poached by some people who are basically starving to death and are desperate. And there are a lot of anti-poaching programs in Nepal, Kenya, Mozambique, and South Africa and Namibia, and even other African countries. They're all experimenting with using drones to try and track down poachers. It's not an easy thing to achieve. I was going to get involved with it, but there are better people at it than me. Like Leanne Pinco, for example, from Princeton University in Zurich, is very much involved with it. And Thomas Snitch, he's a mathematical professor at University of Maryland, is also doing a lot of that. And Google spent $5 million giving grants to make this sort of thing happen. They are making some progress. The poachers get afraid of the idea that there's an eye in the sky and makes them think a little bit twice about getting their picture taken or getting caught. I'm also working on with some falconers a way of using these drones to shoot nets, much the same way that helicopters are used to shoot nets to sort of Spider-Man fashion to catch caribou and moose. And I've also been approached by someone to develop a way to have a drone shoot tranquilizer darts to put animals to sleep so you don't have to use rifles and that sort of thing. You can be a little further away, a little safer. But here are some challenges that we need the drone industry to think about to meet needs for wildlife biologists and wildlife managers. First of all, these planes have to be safe for users and for target wildlife. Smaller is sometimes better because of the portability of it. Longer battery life, so they stay up a lot longer. I mean, those rotary machines, the cheaper ones only stay up for about maybe 15 minutes, and the big, wingspans of around 10 feet, they stay up for maybe an hour and a half. But you can put gas engines on them, they can stay up a lot longer. Decent payloads. Payload meaning how much weight can it carry. There's all kinds of sensors being developed out there, everything from cameras and so on to other things too, detecting moisture. Low maintenance and long shelf life. They got to be rugged because a lot of the terrain that we work in, all of us here that like to hunt and manage wildlife in rugged places, they got to be easy to learn to use. There has to be like a green button concept. In other words, you press a button and the thing does what you want, because they can be quite sophisticated and they're very daunting for a non-geeky guy like me. I rely heavily on my students. Low noise and generally unobtrusive is useful for wildlife studies. They have to have kill switches on them because sometimes the technology, the hardware or software in these things breaks down and you can get a flyaway where your plane just takes off and keeps on going. And can you imagine, there's a company in Ontario here that had a flyaway and they've never ever even found the plane. This was a plane with a 16-foot wingspan just flying happily over the countryside, landing somewhere up in Muskoka, and they never even found it. It doesn't happen very often, but it's something to think about. And finally, sense and avoid technology for beyond line of sight. This is some kind of a little black box that will be in every plane in the sky, including 727s, drones, everything, so they detect each other and avoid each other. I work in very, very rugged locations, birds of prey and gyrfalcons, for example, in the north. Just look at that picture down below and think about trying to land a drone there. So there are ways of these things taking off, everything from hand launches, pneumatic launchers, slingshots off vehicles, off boats, and so on, and recovery. Some of them will land in runways, but they're not always around, or nets, or on the grass, or using parachutes, or even on the water. And I think the ideal way would be to have maybe a vertical takeoff and landing capability. A friend of mine who studied these things up north found that there's a number of things you have to watch out, everything from dust and dirt. Compasses are unreliable up there, GPS, you got wind, you got cold temperatures. And one of the biggest challenges, of course, is the cost of these things. You can buy an X4 Dragonflyer for about $7,000, but nowadays you can also buy a Phantom or a Discovery machine that's about $1,000. You can buy 7 of those for a Dragonfly. My friend Paul Pace came up with an estimate for a fixed-wing one for about $3,000, and that platform is simply a styrofoam platform. You can buy dozens of those and just replace them if they crash. And the sense and avoid technology would allow us to be able to launch planes and do surveys for harlequin ducks and all sorts of neat things. GoPro cameras are probably the best cameras out there to use. They're about $250, and everybody's used them for all sorts of things. And then you've got issues with detectability and imagery, and so you get thousands and thousands of images. Some animals are easier to see than others. For example, look at these bison that we took pictures of, and there's a blow-up picture, and you can easily count those animals. We did some geese surveys, and if you look at Canada geese on my campus and blow it up there, you can count most of them, but some of them are hard to see near the water. But if you look at this picture here, that's a farm field full of snow geese, and you blow that up, there's a program, Photoshop, that can count every single one of those geese with 100% accuracy. And then you can use hyperspectral cameras. This is all those little red dots are basically elk, but you can get some mistakes in there, like those 2 black dots are ones that they failed to detect. Paul Pace studied polar bears up in the North Foxe Basin, and basically using hyperspectral or special lenses was able to turn the polar bears into purple dots, and he got exactly the same count with an unmanned versus a manned helicopter. There are also FLIR cameras that are for infrared, and a little difficult to use for seals and mammals because they're not designed to give off heat signatures, but the birds like ibises and so on that have bare necks do give off a lot of heat. Here's a picture of a barn owl in Africa giving off a heat signature, some impala, vervet monkeys, an ostrich. Look at the heat signature from the neck and the head there, very easy to see. And of course, poachers would be easy to detect with these. The other thing is not all pilots are created equal. Not everybody can fly one of these things. And there are insurance issues out there. You need a $1 million liability insurance policy to get your special flight operations certificate from Transport Canada, and you can't just get those in a week's time. It takes you several months, and it's just very risky for insurance companies, so there's not a lot of them out there. What's really slowing down this industry here, and I'm wrapping up very quickly here, are politicians and lawmakers. I'm not being critical of them. They have to move slowly. But Transport Canada here in Canada, and then the FAA and Homeland Security in the States are in charge of these things. And there are a lot of public perception about UAVs. The word drone is basically perpetuating this. Invasion of privacy issues, safety issues, and legal regulations. These are the latest advances out there that in 2012, Obama signed this special act that's going to provide $63 billion to the FAA to come up with safety rules to use these things. And they expect about 30,000 drones to be flying in the U.S. skies in the next 20 years. Lately, just only 7 days ago, a federal judge with the National Transportation Safety Board overturned the first FAA fine of $10,000 against a guy, saying there wasn't an enforceable FAA rule. And so the FAA is going to appeal, of course. And in Canada here, Transport Canada is bringing in new regulations to ease things for drones under 25 kilograms. And if you take a ground school course for about $200 on the internet, you can get permission to fly these things. And the United States has approved 6 places to study the use of UAVs safely. I want to just basically say to you that we need to have responsible use. These things are becoming cheaper, more sophisticated, and more available and smaller. And the thing is, if I want to fly one, I got to get a permit. If any one of you in the room want to go, you can go to a hobby shop and buy one. You can go fly it right beside Pearson. As long as nothing happens to you, you don't cause any problems, no one's going to say anything to you at all. But as long as it's a hobby thing. But if you're using them for anything where you're going to make some money or it looks like it's professional, it's a very gray area, by the way. So there's potential for abuse, and we have to promote the safe abuse, abuse of these machines. Unmanned Systems Canada is an organization I belong to, and they're working very closely with Transport Canada to do this kind of thing. And I've started this journal up, as Greg mentioned, the Journal of Unmanned Vehicle Systems, for a place to publish papers. I invite you all to send in manuscripts if you're into academic papers. I put this in here last night because I knew you were thinking about this. Okay, this just came out in the news not long ago. These guys were hunting feral pigs in the States and using a fixed-wing drone that basically had an infrared camera on it. You can see a picture in the bottom right of pigs, and they were very successful at it. And this begs the question, should hunters be allowed to use drones to find game to kill? Well, there's no question that they can save hours and miles of tracking, but a lot of guys feel they're unethical and unfair to the game. It's all about having a fair hunt. But the fact is, since the days of Boone and Crockett, where they used to use flintlocks, black powder, and just call with their mouths and so on, now we're using high-powered scopes and ATVs and fish finders. There's lots of sophistication out there. I'm not suggesting, by the way, that we should use drones for hunting. I believe in a fair hunt. But on the other hand, I just want to get the animals on the table to eat. That's my main thing. Lately, just a few days ago, Saskatchewan ruled against the use of drones for hunting. They basically said it's equivalent to aircraft, which are illegal, and that's how they justified it. The fact is that rotary drones can fly for over a mile if you spend like about maybe $30,000 on them. They have limited battery endurance. They can only stay up for about 15, 20 minutes. Fixed wings need a place to land, and it's illegal to fly them beyond line of sight. So I'm not sure if they're really going to suit your purposes anyway. But it does raise some new interesting hunting possibilities, doesn't it? Thank you very much. Yeah, no problem.
If there's any questions for Dr. Bird, please go to the microphones. I know that he has to depart within the next half hour or so. He has another engagement in Montreal, but we're certainly pleased to have him here. Bill, did you have a question?
I guess maybe just a clarification. It's so funny you should end off with the one slide that about a week ago I sent the question to head office, because even in our Moose Gang we had that little discussion, should we be using it? Mm-hmm. And Mark Rickman and from head office has replied to me and has asked our Ministry of Natural Resources, and the answer is we cannot use them. They're going to be considered the same as a fixed-wing plane and all that, that you cannot do get on your feet and do your scouting. You can't do it from the air. So just a clarification for anybody in the room that might have been thinking about drone hunting.
I hadn't even thought of this, actually. In fact, I had a slide in another version of this talk that showed a picture of, like I've been to Kenya 8 times, and we have to travel far and wide in vehicles. There's all kinds of vehicles that are looking for kills overnight where the lion prides are, and that's where you see a lot of wildlife. And I thought, well, wouldn't it be neat if a given tourist hotel could just send a drone out there over the Masai Mara and find that kill instead of all these vehicles going out there looking for them. Or possibly I also showed another picture of a big game hunter, said maybe they could find big game, like a trophy Cape buffalo or something for a hunter or whatever. But I didn't even think about the ethics of all that and so on, and the slide just sort of disappeared from the radar. But then yesterday, someone told me that hunters were thinking about using these things, and so I went last night and messed around a bit with the slides and the internet, and did some thinking about it. And you know, I don't personally see me ever use them or whatever. I mean, I do believe in a fair hunt, but you know, it's a bit of an interesting question, though. Sure.
Fine, entertaining presentation.
Thank you.
It's going to be interesting to see, and do you have a short comment on where will the answer be for this line of sight prohibition stuff? Like, can you project whether recruitment of groups like ours and others that can see the many positive spin-offs from where you're going with this technology, is that not likely able to overwhelm the opposition and negative thinkers where the hazards and safeties and legitimate risks exist? Interesting if you could comment on that. Thank you.
Are you talking about people using them for hunting purposes?
I'm concerned about how do you overcome the line of sight regulations and prohibitions, and where those answers might come from.
Well, what we're all waiting for is this sense and avoid technology. There's a professor named C.O. Young in Canada who's leading the way for Canadians, and it's a holy grail. Whoever discovers a nice, inexpensive way to put little black boxes, so to speak, in these drones and all of the other planes that are taking off from Pearson and so on, whoever does that is going to become a multi-millionaire, because that's going to then open up the possibilities of being able to fly these things beyond line of sight. And that's what everybody's waiting for. The industry right now is stifled because we are allowed to fly these things with permits and so on within visual range, but that's very limiting. And there are companies out there, I mean, you can use these things to find minerals and oil reserves and all kinds of things. Think about the possibilities in northern Canada, what we've got up there. Or we could use it for surveillance against enemies in our entire northern shoreline. This is why I'm surprised that Stephen Harper hasn't put more money into Transport Canada, because, you know, the real bottleneck of this is it's not so much the fact about the regulations, it's having enough people to look at all the applications. The applications each year grow exponentially. They double every year. And I have to wait sometimes. I didn't even get one for Saskatchewan last year. I was 45th in line, and by the time they got to it, the birds had left. So I went to Montana instead. This year we applied a little earlier. But you can, after a while of doing this, you can develop a, what do you call it, a reputation, like a solid reputation with Transport Canada, and get permission to get maybe a blanket. A lot of companies are getting blanket permits now. It doesn't mean they can go anywhere they want and fly them on any given day. They have to let people know that they're going to this GPS coordinate or whatever. But these big companies are getting, they're showing that they're solid citizens and they're going to obey the laws. And the idea of these, of people taking these $200 ground school things is not to teach you how to be a pilot, but it's to teach you how to speak like a pilot. So that when you write up your application, it's going to be in the right lingo, so the Transport Canada guy looking at your application is going to say, I can do this really quickly because this guy knows what he's talking about. Whereas if you get some guy who's, you know, a country bumpkin who doesn't even know the right lingo or whatever and put something in there, and the guy's got to spend like days on it to understand what he means, or go back to him and say, what do you mean by this? Then that slows everything down. So I think that there's no question in my mind this technology is here to stay. It's going to come. It's just a matter of making that one more step. That sense and avoid technology will open up the skies a lot more. But you're not going to see very soon Amazon drones flying all over the city of Toronto. Could you imagine that? All these drones flying around. And I tell you right now, technology is not perfect. And if these things break down or whatever, and you cause a traffic accident or whatever, or fly into someone's face, or there are people out there shooting them down to steal what's on the plane, all sorts of possibilities. I laughed when I saw that Amazon thing, but they seem to think they can do it.
Well, thanks again, David. We appreciate it. You can now see from this presentation this afternoon why we asked Dr. Bird to come back east again. He did a great job at the Congress in 2012. We thought the subject was certainly cutting edge, and you've seen why this afternoon, given the cost of aerial surveys for ungulates in particular, and what it costs to send biologists and planes up there, and governments, you know, who are restrained by costs. This may be the way of the future. So we thought it was a good time for this. I think it was a highly entertaining talk, and we want to thank you very much for coming back again.
Thank you very much. It's my pleasure. A great audience. Thank you.